Welcome, class. As I mentioned, I'm gone today. So hopefully this video works a little better than last time. I'm going to try using a microphone to see if that helps with some of the audio issues we had last time. The first thing I want you to do is make sure that you have your 7-6 practice out. So that was from yesterday. It looks like this. So you should see this on my screen here. The 7-6 special right triangles, if you remember yesterday, we did these 6 together. What I want you to do is after this video, once you get into work time, I'm going to have you hand in the worksheet. But before you do that, I want to make sure that you have a couple of these problems worked through. So we're going to go through a few more. As I said, you should have this done. Just a reminder, 24 and 25, what it is it's coming from an equilateral triangle. So if we look at that 24 there, here's your equilateral triangle. With an equilateral triangle, you have 60 degrees in each corner. What we're doing is we're drawing an altitude in right here so that now you have a 30, 60, 90 triangle. This altitude right here is where that 18 feet comes into play. And it says determine the length of a side of an equilateral triangle. So that's these two sides, and also this whole side right here is that same length. Okay, so we're trying to figure out what is this hypotenuse length or the side length of the whole triangle. And so we had set this up yesterday. I'd kind of shown you what to do. What you need to kind of look at now is just looking at this triangle here. Okay, so if you look at that triangle, the 18, that's going to be your long leg. This down here is your short leg, and then that X that we're looking for, that's your hypotenuse. So if you remember from yesterday, the first thing you really want to do is find your short leg. So we're working on number 24 here. Okay, so our long leg is 18, and to find our short leg from our long leg, we take our long leg divided by the square root of 3. So to find that short leg, we're going to take 18 divided by the square root of 3. We're going to rationalize that. So you get 18 square root of 3 divided by the square root of 9, which is 18 square root of 3 divided by 3. And then 18 divided by 3 is 6. So you get 6 square root of 3. That is your short leg. Okay? Now there are two ways you can go about finding then what the whole side length is. That bottom leg right here, that's divided into 2. So we have half of it. Half of it is 6 square root of 3. If we want the whole thing, we just have to double it. The other way to think about it is that this is your short leg. To find your hypotenuse, you take your short leg times 2. So to find that X, we're taking 6 square root of 3 times 2, and we get 12 square root of 3. Okay, so it wasn't trying to trick you or anything. I just wanted to make sure that you got that one correct. Please make sure that you do your work for number 25 as well, and you show how you found your answer. Another thing that I forgot to mention is that once it's work time, before you hand in this worksheet from yesterday, please go on to Schoology and check and make sure that your answers are correct. It may be in a different form than mine, but overall, they should work. So before you hand in your worksheet from yesterday, make sure to go on Schoology and check it once you have some work time today. Okay? So the other ones I kind of want to go through are still down here, and I know you're probably just aching to get moving on with your next assignment. But number 29, I had a few questions on this yesterday, so I think this one would be a good one to go through. And you kind of want to look at it as two triangles. One triangle is this yellow one, and in this yellow triangle, you have the 90-degree angle right here. You have one 45-degree angle right here in the corner. That automatically means you have this 45 degrees all down here as well. So what you really have is this large triangle here. where this is my side length of y, this is 6, this is 6. And right here you have a right angle. So sorry, my picture is not really great there. But this is just the bigger triangle right there. You have two sides that are 6, and you have those two 45-degree angles. We want to find y. So I would start by finding y. Y is my hypotenuse. And to find our hypotenuse of a 45, 45, 90 triangle, you take your leg times the square root of 2. So to find y, I'm going to take my leg times the square root of 2. So my y value is 6 square root of 2. So then we want to move on and find our x value. Okay, at this point, I would think of it more as a smaller triangle. So maybe take just this yellow part right here. And what has happened is, again, now you have another 45, 45, 90 triangle. This is now your 45, 45. 6 is now your hypotenuse of this triangle. And so if we want to find that x, that's a leg. So to find our leg, when we know our hypotenuse, we take the hypotenuse divided by the square root of 2. So to find x, we're taking 6 divided by the square root of 2. Rationalize that. So we get 6 square root of 2 divided by square root of 4. 6 square root of 2 divided by 2, which gives us 3 square root of 2. That's our answer for what x is equal to, or what that leg is equal to. Okay, so 3 square root of 2. There will be some people that say, couldn't we just have divided that y divided by 2? You could have. So you could have gone 6 square root of 2 divided by 2, and you still would have ended up with this part being 3 square root of 2. Okay. Last one over here. Not sure that you want to go through this one, but I figure might as well. So in this one, you're back to where we have really, you have 3 triangles going on here. You have this big one right here. You have this smaller one here. And you have this other small one right here. And so you kind of have to look at this and figure out which is the best way to go about it. And for me, I like to first just look at this triangle right here. So if I just kind of break that apart on its own. Oops. So say, looks like this. Here's that 90 degrees. This is 30, as seen in the picture. That would automatically make that part right there 90. And we know that this is 2 square root of 3. We're looking for x. Okay, so when I look at this, that 2 square root of 3, that's my hypotenuse. X is going to be my long leg, and over here, this is our short leg. So this right here is the short leg of that triangle that we're looking at here. Short leg, long leg, hypotenuse. And that's the same diagram I've drawn off to the right there. And so I'm going to go ahead and solve for x. So I know my hypotenuse. I want to find my long leg. To do that, I have to find my short leg first. So to find my short leg, I take my hypotenuse divided by the square root, divided by 2. And so to find the short leg, I'm taking 2 square root of 3 divided by 2. And 2 divided by 2 cancels to just be a 1. I get that my short leg is the square root of 3. Now what I'm going to do is draw that into this diagram as well, because it's going to help me with the second part. So I find that square root of 3. Now to find my x, that's my long leg. To find my long leg, I take my short leg times the square root of 3. So my long leg is x, my short leg is the square root of 3 times the square root of 3. That's just going to be the square root of 9, which gives me just a 3. So right there, that x value is 3. Okay, so square root of 3 times the square root of 3. Okay, our short leg is 3. Okay, that gets us our x value now. All that work to get x. Now to find y, if we look at that other triangle that's kind of there, so this one, what that is going to be, you have your 60 degrees here, this would be your 30, and this would be your 90. Y is what we're looking for, and we know that this right here was the square root of 3, because what was the short leg on the first triangle is now the long leg of this triangle. The nice thing about this second part is that we're just trying to find the short leg. We don't have to go and find the short leg and then do extra work. So we just want to find that my short leg, we get that by taking our long leg divided by the square root of 3. So my y is my long leg square root of 3 divided by the square root of 3. Y just gives us a value of 1 then. Okay, so my y value is 1, my x value is 3. Okay. Ooh, oops. Okay. So, down here, really what I'm going to just be looking for, I'm going to be checking that you got through 30 right here. If you did those 48, 55, 56, the answers are in Schoology. As I said, there's no work for it, but you can check your answers before you hand it in, and probably if you did all of your work for number 48, you might get just a little bit, like 1 bonus point or something, okay? Otherwise, if you're through that 30, I would just hand in your worksheet. Don't do it now, just once you get some work time, okay? So now we have to go back and please get out your Chapter 7 note sheet. So the note guide is the packet. We have already filled out everything except the 7-5, and you'll find the 7-5 on page 3. So like the second, today's lesson is called the law of signs, is really what we're focusing on. And the law of signs, what it is it kind of uses just, I apologize, I accidentally exited out there. So 7-5 is talking about the law of signs. The law of signs kind of brings in some of the trig stuff we've been doing and relates it to just some different applications of where it can come into play. So the law of signs can be used with really any triangle. If you think about special right triangles, trigonometry, everything that we've been doing kind of in this chapter, Pythagorean theorem, all of it had to do with right triangles. So that's not exactly true with law of signs. They don't have to be right triangles to use it. It just uses those trig functions because you can, you can derive all of this stuff. We're just going to go over the basics of it, okay? So the law of signs, the first thing is that if you have a triangle, ABC, as you see right here. Okay, we're going to use kind of the same diagram for both the area of a triangle and law of signs. So I'm just going to draw another one off to the side. You may not have room to do this, so I would just look at what I'm doing. Don't do it necessarily. If I have that triangle redrawn over here, A, B, C, you will see that the angles, the vertices of the triangle, are all labeled with capital letters. The sides across from them are the sides that correspond to that angle. So side C is across from angle C, side B is across from angle B, and side A is across from angle A. That's the first thing to realize. If you remember from years past, the area of a triangle, okay, is going to be area equals 1/2 times base times height. Sometimes it's drawn or it's written as base times height divided by 2. But the 1/2 times base times height is kind of what we're going off of. Well, what the law of signs, or what knowing this kind of context of trig, you can rewrite the law of signs so that, we can rewrite the area of a triangle. Okay? If you think about this right here, if you were to draw in an altitude here, we now are going to have a right angle here. This would be considered our height. So if we were trying to find the area of that triangle ABC, you would have to find your height, and then you'd have to take 1/2 that base times the height. Well, what it comes up with is based on, if you draw that in, you now get a right angle right there, okay? And if you were to consider this triangle here, we would be able to make up the trig function that sine of A, its opposite over hypotenuse, it would be that height over that C, that side C. So if you were trying to solve for H, you could multiply by C, you get C times sine of A equals H. So the way that we get this new formula, okay, our original formula is 1/2 base times height. We're going to keep that base, but instead of height, we're going to have C times sine of A. So instead of the height, we use this part right here, C times sine of A. And it's just coming from the fact that right here, this triangle has been redrawn and formed. Okay? You are going to use this. You also have, like, really what has to happen is that you could also say that the area equals 1/2 times A times B times sine of C, or you could say 1/2 times BC, AB, BC, A times C times sine of B. The only real requirement here is that you want to use it when you know two sides and the angle between them. So in this case over here, we just happen to have that our base was B. So we knew B, we knew C, and so we didn't have anything labeled for this side. So that's why we would have used that. I just want to make that clear that it's not always like ABC. It doesn't come out that perfectly, but whatever this angle is right here, the sides should be the other two vertex letters. So if A was the angle, we would use sides B and C. If C is the angle, we use sides A and B. And if B is the angle, we use sides A and C. Whatever sides are not being used as an angle letter, I guess. Okay, so that's the first thing, is that we can use that 1/2 times B times C times sine of A to find an area. Okay. We will do that. It says find the area of triangle ABC. And so we're not going to do that yet because we still need to find like what A is equal to or what C is equal to. So I'm going to jump over to the law of sines here and we'll come back and do that example. So the law of sines, okay, it looks like this. It shows that the law of sines, you could set up this proportion relationship here where sine of A divided by the side length A equals sine of B divided by the side length B, and that equals sine of C over the side length C. So you just end up with all of this relationship right here, and it follows this picture over here. So if you take the sine of that angle divided by this side, oh goodness, that's like equal to the sine of this divided by that side, and then you also have that this one right here divided by this one. They would all be equal to each other. Okay, so if you go and look down, we're going to do this part here. So it says find the length of A. So I look at this triangle over here, and when I do that, the length of A is this side right here. So if I were going to set up this law of sines, sine of A over A equals sine of B over B equals sine of C over C with what I know. I see that angle A is 30 degrees. I see that side A just has an A, we don't know it. I look and I see that sine B, angle B, we don't actually have right there, but you can find it because we know that there are 180 degrees in a triangle. So if you take 180 minus 112 minus 30, we get that that is 38. So you could say sine of 38 divided by side B, which it's across from angle B, which would be that 24. And then we take sine of C, which is the 112, and that's across from the side C. So right now we have this proportion set up, and what we need to do is figure out what A is. So if I just use these two right here, it's going to allow me to solve to find what A is, okay? So I'm going to do that. I'm going to take sine of 30 times 24. So I get 24 times sine of 30, and this is equal to A times sine of 38. Okay. I want to get A by itself, so I put sine of 38 and I divide that. So be careful with how you put this in your calculator, okay? What you want to do is take 24 times sine of 30, okay? And press equals. So you can either write it down or keep it in your calculator, but you want to say equal before you go and divide by sine of 38. So 24 times sine of 30 comes out to 12 on your calculator. So you're going to take 12 divided by sine of 38. And we will get that A is approximately equal to 19.5. So that side length A right there is about 19.5. Okay, so then it also says solve this triangle. So when it says solve, you want to find all the angle measures plus all your side lengths. So if I look at the picture there and what I've done so far, I should know that the measure of angle A is 30. The measure of angle B, we already found that, that was 38. The measure of angle C is 112. Those are things that we already know. We want to find our side length of A, our side length of B, and our side length of C. Well, we just found A, it was 19.5. We were given B is 24, so now we just have to find the length of C. And to do that, you can now use, if you go back and look at right here, we can use these two in the proportion to solve for that C value. So for that one, I'm just going to write over here, sine of 38 divided by 24 equals sine of 112 divided by C. I do my cross multiplication. Okay, I'm going to divide by that sine of 38 to get C by itself. And so 24 times sine of 112. If you type that in your calculator, we should get about a 22.3 or 25 if you just leave it in your calculator how it is. And then after you hit equals, just say divided by sine of 38. What should come out to be is about 36.1. So that side length C is about 36.1. Okay. So to solve it, you set up all those different ratios proportions there, and then you're going to solve it to get all the angles, all the sides. Okay. Now let's jump back to what we started with today, the area of a triangle. So you just have to pick what angle you want to work with here because we know all of them. We know that this is 38 degrees. We also know all the side lengths. So it doesn't matter which one you pick. We're just going to say area equals, say, 1/2 times B times C times sine of A. Let's just use what we started with. So that area, if we take 1/2 times my side length of B, my side length of B is 24. My side length of C is 36.1. And my sine of A, well, A is 30. So we get 1/2 times 24 times 36.1 times sine of 30. So 0.5 times 24 times 36.1 times sine of 30. What we end up with is that our area is about 216.6 units squared. So when you have area, you square whatever units it is. This one didn't specify if it was feet, centimeters, etc. So we just say units squared. Okay. So that is your general thing there. Okay, the area equals 216.6 units squared. Okay. So I know that was only one example of the area of a triangle, but that's kind of all there is to it. You find an angle you want to use, usually it's going to be the one that's given to you, and you find the two sides on either side of that angle. Those are what you're going to use for your formula. Okay. So take a moment right now. You're going to have the worksheet passed out from the sub. So when you get your worksheet, I will go through a couple just because I know there's not a lot of examples on here. I know you might be sick of hearing me speak, but I want to make sure that you really you get to see more examples. So get your worksheet handed out. You can pause this video if you need to get that. Otherwise, I'm just going to jump right into it. So your paper should look like this. It says 7-5, Law of Sines Practice. So make sure your name is at the top. If we just quick go through an overview of it, there are 9 problems that want you to find the area. And then 10, 11, 12, 13, 14, 15 want you to solve the triangle, which means you want to come up with all the side lengths, all the angles. Number 16 is just a short word problem, and number 17 is just a graphic. It's a multiple choice question. So I'm going to go through a couple of these, as I said, and then I'll leave you to go onto your own to finish it. Okay. So number 1, if we look at that, and the area, the general relationship for area is that we take 1/2 times the 2 sides, and then an angle that's sandwiched between them. So, apologize, that just came out of nowhere. So it's that pattern where B and C are the 2 sides, and then the angle that you use is whatever side letter didn't get used. So when I look at this one right here, here's my angle I want to use. So like I'm going to be using the sine of angle C, or sine of 45. The way I set it up, I say that my area is 1/2. The letters do not matter as much. I'm just going to take my 2 side lengths, 5 times 6, because those are the 2 sides, A and B, and then I'm going to use C. So sorry, C right there should be a 45 degrees. So I set it up like that. Now at this point, you can just type it in your calculator. 0.5 times 5 times 6 times sine of 45. And I get that is about 10.6 kilometers squared. Okay, so I just go and I find the 2 sides on either side and use the sine of the angle that I'm given. So the next one, let's just look at this one. Again, this is like your side B. This one is your side C, and that's angle A. So if you want to, again, use that one that I was just, that I wrote at the top of the page, 1/2 times my side B, which is 16, times my side, which is C, which is 20, times the sine of A, or the sine of 52. Set it up like that. The two sides you're given, the angle that's sandwiched between them. So 0.5 times 16 times 20 times sine of 52. Write that all in your calculator, multiply it all, and we get 126.1 square feet. Okay, so for those last 1, 2, 3, 4 there that have the pictures, all you have to do is set that up. They give you two sides. They give you an angle that's sandwiched between them. You will see in number 3 and 4, they give you a little bit of extra information. Okay, so weed out what's important, weed out what you have to use. Okay, so like on number 4, you're using this angle here because that's the one that has that sandwich between those two sides. And then for number 3, you're going to be using that angle because that's the one that's sandwiched between those two sides. So that's just a little hint to get you started right there. Okay. Number 7, it's really not any different. All it does is it doesn't give you the picture. But if you think about it, we have A, B, C. It tells us that angle C is 25. We know that side A, which is across from angle A, is 4. And we know side B, which is across from angle B, is 7. So this one, we're just going to take our area is 1/2 times my A, the length of A, which is 4, times the length of B, which is 7, times that sine of angle C, or sine of 25. I type it in, 0.5 times 4 times 7 times sine of 25. And I get that my area is about 5.9 square feet. Okay. So 5.9 square feet. So it might be helpful for you to draw the pictures. Otherwise, the way it has it set up, just kind of follow the pattern that we've been doing. Okay. The next part, it says solve the triangles. So again, this is where you want to find all the side lengths, all the angles. What I did for the first two is I wrote in the ones that are given to you in the picture. So I wrote in anything that was given in the picture, already filled in. You just have to find the remaining. When you look at 12, 13, 14, 15, you're going to have to put everything in the correct space. Okay, so let's just look at number 10 right here. What I would always just do, I like to always start with the easiest thing. So I would start by finding that measure of angle C and think to yourself or say out loud, how many degrees does a triangle have? So a triangle has 180 degrees. So if we know that one of those degree angles is 44 and the other is 106, if we subtract that out, we get that the measure of angle C is 30 degrees. Okay, so there's our pretty simple one. We can either use law of sines, you could use some trig functions if you wanted to. Because we're in the law of sines, oh, sorry, I said you could use trig functions, but that would be reserved for right triangles. So use the law of sines to find B and C now. So I'm going to say that sine of B, sine of 106, because B is 106, divided by B equals my sine of A is 44 degrees, over my side A equals my sine of 30, sine of C, divided by that side length C. So I set up this proportion, and I can think of head because I've done this so many times, but I put that sine of 44 in the middle because that's the one I know both parts of. And so you're going to want to find these ones that are circled. Those are the two that you're setting up to find B and C. Okay, so I go and I set this up. I say sine of 106 divided by B equals sine of 44 divided by 8. I do my cross multiplication. Again, that 8 times sine of 106, just type it in your calculator, hit equals, and then you're going to divide by sine of 44. So you take that number divided by sine of 44, and we get that our side length B is about 11.1. So B is about 11.1. Now I'm going to go to the orange one, and I say that sine of 44 divided by 8 equals sine of 30 divided by C. Do my cross multiplication, so sine of 44 times C equals 8 times sine of 30. I divide by sine of 44. So in my calculator, remember, take 8 times sine of 30, hit equals. Then you're going to divide that number by sine of 44, and you'll get that C is about 5.8. Okay, so we go and we write that in. So basically that's what you're going to do for the rest of them. The angle you just find by taking the 180 minus what you know, and then the side lengths you set up the law of sines to solve for those missing side lengths. You will see that the angles kind of change, SRT, M, and L. It's the same thing. Sine of M would be divided by side M. Sine of L divided by side L, and so on. Okay. 14, 15, the only difference with these again is that you don't have a picture. So just draw it however you want. It doesn't have to be to scale. But if I draw it out, it says angle P is 190 degrees, so I mark it. Angle Q is 57 degrees. Side N, which is across from angle N over here, is 22. And so it wants us to find side P, side Q, and angle N. So I would substitute in, I know that angle P is 109, angle Q is 57 degrees, and I know that side N is 22. I would want to just go ahead, find angle N, find side P, side Q by using law of sines. The last one, it's just a simple little word problem there. It's pretty much the same thing. It wants you to find this angle right here, and then it wants you to find the distance right here. So it's basically like you're solving a triangle. You'll probably just have to use, well, you will have to use law of sines to solve for a side and an angle. Okay, so just do your best on that one. And then number 17, it's sort of the same. Do your best, work through it with what we've been doing in this lesson here. Okay. Thank you for listening. I know it had gotten probably a little bit long, especially since I'm not there. You might still be confused, so if that's the case, just make sure that you can talk it over quietly with the people around you. Please take the time to really work on this. If you get stuck, you can watch other YouTube videos that kind of explain it if you need to. But I hope that there's enough in your notes and I've gone through enough examples that you at least feel pretty comfortable getting most of this done on your own. Okay, so please work quietly. Make sure you get yesterday's assignment handed in. Check your answers on Schoology before you hand that in. And I will see you tomorrow. Okay, thank you so much. Please email me if you have questions. And I will see you tomorrow. Okay, thanks. Bye.